Okay, so we are recording now, guys. So, guys, my name is Roshan. I'll be the instructor for this workshop. Just coming to before we get started on the workshop agenda, just would like to introduce myself, guys. So, I have around 16 years of experience in IT, working with all the cloud service providers, hands-on, AWS, Azure, and GCP. Currently, I'm a principal SI with one of the retail giants. I have as a background, I have experience. I started my career into Java engineering, Java performance engineering, basically Java developer, and then I moved into Java engineering, performance engineering to troubleshooting Java applications, and then I have been taking multiple roles as a DevOps consultant. I have been in the last 10 years. I have been a principal DevOps consultant, and currently from last 3 to 4 years, I am a principal SRE, right? Working with various tools like shell scripting, Python, Ansible, Terraform, Kubernetes is one of my expertise. Working on multiple Kubernetes engines, right? GK, Google Kubernetes Engine, EKS, Elastic Kubernetes Engine service, and AKS, Azure Kubernetes Service as well. So that's the background about me, guys. So today we have gathered here to talk about a workshop on this, and at the end, so this workshop, the agenda is to understand why do we call cloud elastic. Okay, why cloud is called elastic, why we call cloud elastic, right? So we understand this. Basically, we have a feature called auto scaling in the cloud. That's one of the features, auto scaling group, that we have in the cloud, which we don't have in on-premise. Okay, so we'll understand that why we call cloud elastic, how it works, and what it offers. The most important, how it impacts the cost for any organization, how it contributes, auto scaling group, and you would understand in just a while that how it's gonna impact the cost significantly for any organization, the auto scaling group, right? So we'll talk about load balancer also in some time. So these are the, and then on what all basis we're gonna auto scale. So these are the topics that we're gonna go over in this workshop, 1 hour. So I would like to just talk about some kind of a 50% theoretical knowledge and 50% I'll do a hands-on here. I have, as you can see, I have logged in into one of the AWS Cloud Console. I hope you guys can see the screen, AWS Cloud Console. I'll just demo there, right? And at the end, I'm coming up with a course. I'll introduce you with that, right? On the SRE, site reliability engineer, and as well as on the cloud performance engineering. So I'll talk about that at the end, last 10 minutes, okay? So you can plan your this next 1 hour accordingly. Okay, so guys, to get started, I hope just to get, since I have introduced myself, I would like to understand. I do see some 14 people have joined. I know that most of the guys I interact here are mostly performance testers, engineers. Is it the same case with this forum as well? Are we all from the performance background, performance testers working on various tools, Jmeter, load runner, and Neoload or Gatling, and then into Java performance engineering, looking into thread dump, heap dump, analysis, troubleshooting Java applications, right? Are we in the same forum, or is anyone apart from this forum? Please do let me know so that I can guide you better where you can use this, whatever we are going to cover in this next 1 hour. Guys, please help me with your introduction, just in few lines, your skill sets, and how many years of experience you have. Just help me that quickly in the next 1 minute, guys, please. You can use the chat option. I would prefer everyone just put in the chat so that I get a consensus of my audience here so that I can talk accordingly. Please help me.
Myself, Shahenshah. I have 3 years of experience in performance testing and 6 months of experience in automation. So just I have done course like DevOps. So I know just little bit basic things about that one.
Okay, good to know. Guys, please help me. Others, please help me. Use the chat option, guys. Anyone would like to unmute yourself?
Hi.
Hi.
Hi. I am Eknur, and I'm a performance tester from past 6 years, and I have experience on load runner, Jmeter, and Neoload. From performance engineering, I'm still learning all the new concepts, and currently, like, I'm also load testing some cloud applications. So this forum or this course will really help me out. Yeah.
Good to know, Ekman. Welcome. I do see that Tarun, 7 years of IT experience working with performance tester. Good. Nadeem, 7 years, load and expert. Good to know. Tarun, Nadeem, welcome. Okay. Others, just let's finish that in just next 1 minute, guys. I would like to devote as much time in learning something. I would like to make sure that you 1 hour you feel whatever time you're spending worth. So please complete that introduction part in the next 1 minute. Highly appreciate that. Okay, very smart. 2 years of performance testing. So yes, so I do get a consensus, right? So Raj, 6 years performance tester. So everyone, Loader, Jmeter, Dynatrace, right? So yes, I think most of the folks are in the performance background. I like this. See, first of all, I myself is from. I started my career into Java development, right? And then I moved into performance engineering. This particular field fascinates me, uh, makes me do things which I would never have done as a developer, right? Looking into troubleshooting Java performance applications, basically the application performance. How can we make it better? It's not about just identifying what is the problem, but to get to the root cause and fixing it, right? That's the end part of it, right? That's what we call performance engineering. Engineering is not about what is the problem. We need to fix the problem. That's the engineering part, right? We need to talk about code optimization, what data structure to use, how to write the code better. You need to talk to developers, how they have written the code, what they have been thinking. You need to understand the functionality also. A lot of things goes into it to tune your application, right? And apart from that, you also do all sorts of performance testing, monitoring, right? Grafana, as people are talking here, Sidescope, Dynatrace, Grafana. Yes, we have Prometheus, we have uh, ELK stack. We have so many things, right? Now we are into microservices world. We talk about containers, we talk about pods, we talk about Kubernetes. All things are coming, right? And we talk about automation at the end, at the core. It's all about automation and the cost optimization. That is never going to fade away. That's the most important part. How we going to cost optimize things, and we can always do through automation, right? We always try to use what can we do to automate things so that the cost can be optimized, right? Using any automation tools like Jenkins, creating CI/CD pipeline, or using Terraform for infrastructure automation, or Ansible using configuration. And it's all about automation, making your mundane task repetitive task so that things can be done in a much efficient manner. Okay, good. Thank you guys so much for the wonderful introduction. Let's get right to the topic here. So we call cloud elastic. Why do we call cloud elastic? See, understand, we need to understand this problem, why we call cloud elastic, we need to understand what is cloud first. What is cloud and how it is different than on-premise? Can anyone just quickly help me understand what is cloud and on-premise? Uh, anyone, just quickly, in just next 1 minute. I would like to just take one or two
Uh,
from you guys.
On premise is like the physical servers we have, like in our organizations or in our company, and cloud is like something we get from some cloud provider like AWS or Azure, and where we can have unlimited storage.
See, and the end you are using the servers, correct? They're not denying the fact, right?
Yes.
And then either you on-prem or cloud. What is different? I want to understand. What does it? How does it differ? Either it's on-premise, right? So basically, whether you own it or you rent it, that's what the difference is, right? Because I'm going to use servers to deploy my applications, on-premise or cloud, whatever the case is, I'm going to use the servers, right? And if why we call on-premise, because I call on-premise because I work in the company and that company owns the data center. That company owns the data center. The company owns all the hardware, all the servers, all the operating systems, everything the company has set it up. That's we call on-premise. A lot of dollars investment goes into setting up a data center. A lot of dollars, significant amount of dollars. Not everyone can build a data center, right? I would like to just you to imagine this when I call a data center. When I call a data center, imagine something like of this. Imagine a full building and 4 to 5 acres of land in the outskirts of the city and an infrastructure build up, right? 4 to 5 acres of land you need to acquire, you need to build the infrastructure, multi-story building, and then you will have to put a lot of servers in it like this. So this is called a data center. This is called a data center. A lot of land you have to acquire, build the infrastructure, purchase all the servers. That's what a data center looks like. It gives a huge amount of investment. You can look at there are so many servers generating so much of heat, right? You need to do cooling mechanism also, right? You need to have multiple power supplies, multiple internet service providers. Power servers cannot have any power outage, right? So you'll have to have multiple of everything. That's what a data center looks like. So if a company owns it and you work in that company, that becomes on-premise. If you use someone else's hardware, let's say AWS has set up some data centers all across the globe. Azure has set up data centers all across the globe. GCP has set up data centers all across the globe. I'm gonna go to AWS, boss. I need to use some servers, 10 servers, 20 servers, 100 servers. I need to use it. I'll pay you this much amount. Can I use it? That becomes cloud for me. At the end, I'm using the servers. Either it's on-premise or cloud. That's what the difference is. Whether you own it or you rent it. So cloud is about renting. You don't own anything. You just, someone else has set up a data center. You're gonna ask them, can I use these servers for few number of months on, and they will tell you, you need to pay this much monthly amount. That's how you need to sign a contract with them. And that's how you go and ask servers. And you don't need to call them. What they have done, the major cloud service providers, all AWS, Azure, and GCP, they have given this beautiful cloud console, management console. You log in, you get the account created, anything, AWS, Azure, GCP, you go and get the servers from here. And they would do the billing. They have all the billing mechanism for you. They would do the billing. If you want to get the EC2, want to get the server, the first thing that we would like to get is the servers, right? We have web server, app server, database server. We need servers to be deployed first. So in AWS, we have a service called EC2, right? EC2 stands for Elastic Compute Cloud. We go and get the servers. If you go to the GCP part, right? Let's say I'm going to log into GCP. They call it compute. The UI would change, right? The look and feel will change. But at the end of the day, all the cloud service providers have the same functions. They're gonna servers. You can go and take the servers. In the GCP cloud, we call it compute. Good. I request everybody, guys, please. You can ask the question, but wait for the right time. Okay? Please be on mute. I'm going to give you ample time to ask questions, right? When I'm speaking something, explain something, hold on. Okay. So that's the compute here, right? So look at the virtual VMs. I can go to virtual VM instance. I can get some VMs. VMs, you call it instances, you call it servers, you call it EC2. See, EC2 is just the name given by AWS. Same thing, if I log into Azure portal, they call it virtual machines. All in the same thing, right? Doesn't matter. The functions across all the cloud service providers remain the same. This is the servers. If you want some storage, right? You want to store something. They have multiple storage services. In AWS, S3 is one of the popular storage services. We have simple storage service, we call it. If you go into GCP, they have a similar service called cloud storage. We have a similar service called cloud storage. I can go to cloud storage, create some buckets, and I can store anything I want. Object storage, we call it. Object could be anything. File, movie, audio file, GIF file, any extension. I can output anything, a JPEG. I can get a bucket storage. So we use cloud to get servers so that I can deploy my applications. I can get some storage services so that I can store something which I want, right? So similarly, we have multiple services. Okay, we have multiple services for different use case. We have lot many use case, right? We have lot many use case. Let's say, for example, if you need a load balancer, you have multiple web servers. So let's say you got the servers. You have EC2 instance. You got some servers. You got some web server, app server, database server. You got it. But let's say you have multiple web servers, and you need to load balance the traffic across all the web servers. You have multiple application servers. You need database, right? So here they have database services also. If you go to AWS, they have database service also. Multiple databases there. Mostly you may be aware of the relational database, and some of you would be aware of few non-relational databases, but we have multiple databases. In the relational database space, we have MySQL, Oracle, Microsoft SQL Server. In NoSQL space, we have Cassandra database, we have MongoDB database, we have MongoDB is what we call it, document DB in AWS. We have DynamoDB, it's a NoSQL key value pair database, right? Key spaces is what like Cassandra we use it, right? So we have multiple database. If you want to use a managed service, see, I'll just take one of the example of how these database services are used. So you guys in on-premise, how we work? We get a server and we install the database, right? We install it. A DBA would install it. Our performance engineers are expected to do anything, right? Nowadays, we are that way. We are those skill set people that anything is expected from a performance engineer. So we also install database, right? Or a particular DBA would install a database, right? And then we application development do, and we kind of write our query for the depending on the application that we develop, right? In these, if you use these databases, you don't have to install databases. Cloud would do a lot of automation for you. A lot of automation goes into for a managed service. So all the cloud service providers, see, whatever I'm talking about AWS, don't think that those things are not there in Azure or GCP. I cannot talk about multiple things for, let's say, if I talk about one cloud service provider, take it for granted that it is available for the same things available for the other cloud service providers as well. So when I say managed database service, managed, right? If I say managed, so what you can do, I can just go to, let's say, relational database. I hope most of you are aware of relational database. I'm going to go there. And let's say I'm going to go and select some Oracle database or MySQL database. Let's say I'm going to select that. I don't need to install it. The installation part has been taken care by the cloud itself. Only the development part, the SQL tuning part is what is pending. What you're supposed to do if you use this managed database. Isn't it the greatest thing, one of the coolest thing, right? You don't have to install database. I can just click on create database. I can select database of my liking, of my requirement, whatever. I can go ahead and select MySQL, Oracle, SQL Server. I can just select in one of the databases. I can select whatever version I need. Let's say Oracle database, I selected this. I'll just select whatever version I need, Oracle Enterprise Edition or Standard Edition. I can select any one of these two. Obviously, I will have to pay for the licenses. That's another thing because Oracle is not open source, right? If you use MySQL, you don't have to pay for the licenses. MySQL is open source. But if you use Oracle, that to Enterprise Edition, it's going to cost you heavily, right? Because AWS has to pay to Oracle. Like let's say you selected Enterprise Edition. You can go and select 19C or whatever, 21C has come. 19C is there. 21C, 22C is not there. So you can select this 19C. You can give a database name. You can give this username. You can give some password. That's how you will log in to the database. Or you can select the machine type. What's the core, the RAM of your hardware that you want to install your database? I can go ahead and select 4 vCPU, 16 GB RAM, or if I need 4, I can go 8 vCPU, 30 GB RAM, I can get it. Depending on my use case, I can get it. Any question, guys? Someone wants to ask any question? someone wants to ask any question, you can ask me. Okay, guys, you can stop me if you're not following. So you can stop me. I hope I'm not going fast, guys. All good? Please confirm in the chat. All good? Yes?
Yeah, all good.
Okay, perfect. Good. So depending on, so I can go ahead and select any. Guys, I request you, please be on mute. Okay, I get distracted. If you have something to ask, you can ask me. Okay, so you can go and select 4 vCPU, 8 GB, 8 vCPU, 30 GB RAM, depending on the requirement, right? So you don't have to install database. That's what I'm telling, right? I can select whatever I need, Oracle, version, right? All the things. You don't have to worry about auto scaling, storage auto scaling. We often face this problem, right? Disk out of space, right? Disk out of space. We don't have enough space in the disk. If you click this option, you will never run out of disk. You can give a maximum threshold of the disk size, and it will be growing automatically as and when you require. If you want to go for multi-AG deployment for high availability, AZ is nothing but a data center. Okay, AZ, what I mean here is a data center. So multi-AZ means multiple data centers, right? I can go, so basically I'm in Mumbai region right now. So Mumbai region has 3 AZs, 3 data centers, okay? AZ1, AZ2, AZ3. Mumbai is a region. Similarly, I have 28, 29 regions all across the globe. And one region usually has 2 or more than 2 availability zones, means data centers. I just showed you how a data center would look. So if I deploy this multi-AG, basically I'm telling I'm going to deploy my database here as well as here. So I'm going to be highly available. So let's say by any chance, if this goes down, I have this to take care of my request. My application will not be having downtime because of the database. That's what this means. Just click of a button. That's all. Click of a button, your multi-AG deployment. And I can give all the things and I can just click create database. It will take 20 minutes, 15 minutes. My database will be ready. The automation at its peak. The automation at its peak. So we often define, so I told you, right? We often define, so the first definition of cloud was computing based on the internet. The first definition of the cloud is computing based on the internet. Because I told you, right, that I'm going to rent it and they have given this beautiful cloud console for me to create whatever I need, and they're going to do a billing. They have a billing service again, like EC2 database. They have a billing service also. They will calculate billing. You will get the monthly bills. If you don't pay it, you will not be able to continue with the services. As simple as that. So you are basically the chef. This is the kitchen, and you're gonna be the master chef. You're gonna create whatever you want. Master architect, basically, right? That's how. And the computing based on the internet, I can create servers anywhere I want across the globe, sitting remotely. I don't need to be in that particular location. I selected Mumbai right now, by default selected Mumbai. If let's say my customer base is gonna be in US, let's say that in US, I don't need to create a server in Mumbai, right? Why do I want unnecessarily latency? There is no reason for me to have unnecessarily latency, right? I want to avoid that. How can I avoid that? By creating servers, by deploying servers in US, North California, Ohio, US East region, US West region. I can go and create their servers. I can deploy my servers there so that if my customers are accessing my application, whatever I have deployed, they get the best performance. There is no latency, right? So there are multiple ways to select. Why do I select a particular region? We need to understand, depending on my customer base, latency, and all those factors come into picture. The second most useful definition. So basically, I'm using all the services based on the internet. I don't need to be physically there, but I can create servers there. I can deploy my application. I can have a database there. I can set up everything from remotely. I don't need to be there. That's the best part of cloud. And the second most definition, the best definition I like about the cloud is the virtualization plus automation. Because see, it's because of virtualization that's everything is happening. You are able to create a server, one vCPU, two vCPU, four vCPU, 8 GB RAM. You are able to customize things. It is because of virtualization. The idea that you can create VMs remotely is what virtualization. Virtualization can happen at any layer, right? At the storage layer, at the compute level, network layer, any layer. So virtualization is very important key. Back in 1980s, so when the software deployment started, we used to deploy everything on a big physical server, tiny little application. Few KBs, few MBs application we used to deploy in a big physical server. We used to waste a lot of resources. Then there come a technology called virtualization, and that enabled us to create VMs. We can create VMs. When I say I'm going to create EC2 instance, basically I'm talking about I'm going to create a VM. And AWS, Azure, GCP, those guys have already done the virtualization. That's why I'm able to create a VM of my choice, one vCPU, two vCPU, 4 GB RAM, whatever need I need, any specification that I require. And automation at its peak. You can see they have given this on-demand self-service. You don't need to call their data center call centers to ask, I need this server, that server. No, everything is at your disposal. On-demand self-service. That's the automation for you. So there are two definitions of the cloud. I always prefer this to the computing based on the internet, the use of hardware and software over the internet. And the second definition is virtualization plus automation. It's so simple, right? And that's why not every company can afford to build a data center. That's why there's so many startups, because we are using cloud now. The data center setting up a data center is no more a bottleneck. If I have a business idea, if I have some business idea, I can go to any cloud service provider. I can create servers. I can run my application in the pilot mode with a small number of servers. If it goes well, I can expand with a click of a button. If my business is growing, let's say I'm starting up, I just need few servers, 10 servers. I may cost me like $2,000 per month to start with. I have that much amount of money, but I cannot have that much of amount of money to set up a data center and try this out. What if my business doesn't work? Right? So all these things, so many startups are coming up because the setting up a data center is no more a bottleneck now. Right? I can just, and if your business grows, you can get more servers with a click of a button. Today, if you need 20 servers, tomorrow, if you need 100 servers, click of a button. They are ready to give you. That's their business. AWS, Azure, GCP, that's their business. So that's the nutshell about the cloud, guys. I hope I hope I could give you some better perspective of cloud. Yes. Can I get some acknowledgement from all of you? Any questions till this point of time, guys? I'm gonna talk about load balancer and auto scaling group now. Any question till this point of time?
So it's all like on the like some cost based model. Is it this like?
See, pay as you go. Pay as you go. If you are using EC2 instance for 1 hour, you're gonna pay for 1 hour. If you use EC2 instance for 2 hours, you're gonna pay for 2 hours. If you use store something, if you use S3 or their other storage services, EFS or EBS, if they use some of the service, they're gonna charge you. If you're not using it, they're not gonna bill you. If I will not do anything, they're not gonna bill me. Pay as you go. There is no minimum, maximum. It all depends how much you use. That's how the billing works. Pay as you go. One of the very word that you would hear. Pay as you go. Pay as you go. That's what you will be billed as per your usage. Okay. Any question, guys? I'm going to give a minute or two. anything that you want to ask on the definition part or understanding part? Okay. Silence means everyone on the same page. Good. Okay. So we have guys
We're
done
fine,
that.
Roshan. Yeah,
Good.
I'm fine.
Okay, good. Yeah. See, when AWS was launched, right? Let's say back in 2007, right? So they launched with 3 services. You know why AWS was launched? Jeff Bezos, right? He's the guy behind AWS, right? He's the owner. So he was trying to set up data center for one website. I hope you know this website, Amazon.com. I hope you know this. Everyone knows this, right? He was trying to set up a data center for this website. And he eventually realized, he got one more business idea, that if whatever I'm doing, why can't I leverage this to the entire world? That was the inception of this AWS. The way he was setting up the data center, and he thought, why can't I create some sort of on-demand self-service where people can go and create servers? Why they have to invest so much? And he just did this, right? He had this vision back in 2000 when he was setting up data center for AWS for Amazon.com itself back in early 2000s. And that's why this AWS came. When AWS was launched, they launched with 3 services only: EC2, S3, and SQS. These 3 services, only these 3 services back in 2007. You know how many services they have it now? Any guesses, guys? Any guesses? How many services they have it now?
Maybe 300.
200 plus. 200 plus.
Okay.
200 plus. Look at this. Everything. Compute. In the compute, they had just EC2, but now they have Lambda and whatnot, batch. Depending on all the AWS is the most customer-centric cloud service provider. If a customer has a problem, they're going to create a service around that. And if they see a potential number of significant number of customers have the similar issue, similar problem, they're going to create a service for that. On the they have in the blockchain now, they are coming up everything, databases, they are into game development, they are into Internet of Things, they're into machine learning. It's coming up, it's growing. It's going to keep growing.
But Roshan, I have one question. So do they have a private cloud option from AWS?
Yes, they also have it, but mostly, see, unless you want to purchase a private cloud, you can go ahead and talk about that. But at the end, you need to know these services, because that's what they will offer. Right. So private cloud is the data center where you can only deploy the applications, deploy the servers, can get the servers. If I say Mumbai, if I rent the complete data center itself, that's the private cloud. No one else can get and servers there. That's the private cloud for you. Right? They also offer. There are other players also they offer. Right? Yes, I think they offer. But at the end, whatever the private cloud or public cloud, you need to know the services what they use. But at the end, you're gonna own the complete, basically rented the complete data center itself. But at the end, all the services will remain the same. Right? Look at this. They have in this entire globe. They have covered robotics, satellite. If you want to doing some communication with satellites or building something on robotics, media services, machine learning. They have, name it, storage services. They only came with S3, but now they have EFS, Glacier, storage gateway. They have many things. Right? 200 plus services, and still growing. And not just with AWS, Azure and GCP have the same story. Only difference with that they started quite late. AWS came in 2007. They came around, Azure and GCP guys came around 2012-13. AWS had a 5 years ahead of them. All are doing great. And that's why AWS is the most popular, okay, first of all, because they are 5 years ahead in the game.
The AWS can support even the old legacy ERP applications like SAP or something, right?
See,
It supports everything,
again,
right?
understand this. Why, either it is SAP, at the end it's a server. See, you're not getting it. See, when I say at the end, what you're using? Servers only, right?
Yeah, the servers, the required plugins or utilities,
Whatever.
the
At the end, you need
compatibility.
the servers, VMs, storage services. That is not changing. As it's on-premise or cloud, that does not matter. That's the definition is. That's the bottom point. That's the bottom line. It doesn't matter. It will support everything. If you want to run SAP, you go and run it. You need servers. They will give you the server. You can install SAP there, deploy SAP there. They're gonna give you the servers. Doesn't matter for them. Doesn't matter for them. On-premise, what you do? You get servers only, right?
Okay.
Cloud is also same thing. Okay. So coming to this part. So coming to this, the fundamental point here, the scaling, the auto scaling when I talk about it. So if you go to this EC2 service, one of the popular, as I told you, it's the first services that you can go and get servers. You can go and get some servers for you and you can deploy some web servers, app server, database servers. You can get the servers here using EC2, Elastic Compute Cloud. It stands for. And if you see here, we have something called load balancing and auto scaling group. So you need to set up here. So how it works, basically, let me draw some architecture diagram. Okay. So let's say if you have a one web, let's say I'm talking about the normal 3-tier application. Let's say I have a web server, app server, database server. Let's say if I have this setup, users are accessing the web server, they're hitting the web server is interacting with the applicant server is taking the information from the database server, DML, insert operation or select operation, whatever. So let's say this is a simple 3-tier application. All good. You don't need a load balancer here. You do if you have only one server, you don't need load balancer. You don't need load auto scaling group. You don't require all of these things. If you have a single server, things get complicated, or you need to manage when you have multiple web servers. So why do we need multiple web servers? Because I don't want to have a single point of failure. I want to achieve high availability. I want to achieve high availability. I don't want my users to get downtime. I don't want downtime for my users. I want high availability. So the next question comes: how would you achieve high availability? Simple. Let's say one region. Let's talk about one region. Any region, okay? I have multiple AZs. AZ1 availability zone. Okay, AZ is the availability zone. AZ is like a data center. So Mumbai also has 3 data centers. Okay, they have 29 regions. Okay, by the way. So let's say how to achieve high availability. Always deploy multi-node per AZ. First of all, first approach is that deploy multi-node. Whatever, web server, app server, data, not DB. DB we can manage with just 2. One primary, one failover. Let's say talk about web server first. Web server and app server. So multi-node. Go for first multi-node. Multi-node per AZ. Why? Because if one server goes down, I have other server. Good. What if the entire AZ goes down? Okay. In that case, have multi-AZ deployment. Because it's very unlikely that 2 availability zones would go down at the same time. Because these AZs are quite a good distance apart. Let's say natural calamity happened. These AZs are like 150 to 200 kilometers apart. That's why that's the idea, because the AZs are quite a distance. First of all, it's very difficult to bring one AZ down. It's not likely. Setting up a data center, it's a task because you have multiple power sources, you have multiple power backups. First of all, normally electricity would be there, multiple generators, multiple network switches, multiple of everything. Or for everything there is a backup, because AWS guarantees you, when you take their services, you write a contract them, you get a sign that they're gonna promise you that their servers will be available for this much time. If they are failing with the contract, you can sue them, or they will have to pay some penalty. You'll have to give them penalty. So there are some high availability SLA are also there in the picture. So very difficult to get one AG down. Complete flood came into building and complete building is full of water. That can be the only scenario that AZ can go down. Okay. So I'm going with multi-node per AZ. And then what if, so I told you, right? So one entire AZ goes down if I go for multi-AZ deployment. So that's why I don't have only one web server. Let's say if I'm talking about a production server, right? Production scenario, I don't have only one web server, one app server, database server. I basically have multiple of these things. W2, W3, W4. Same thing for here as well. Application servers. A1, A2, A3, A4. So obviously, you just are going to hit only one URL, right? Amazon.com. If they have multiple web server, doesn't mean that you just will hit Amazon1.com, Amazon2.com, Amazon3.com, right? So obviously, I'll have a load balancer at the top where you would be hitting, and then this load balancer is going to redirect my request to all my web servers. So this is going to be external load balancer, internet facing, right? And then again, I have web servers, multiple web servers. Then how, and I have multiple application servers also. Then how the traffic is going to flow here. So I will also create one load balancer here, internal load balancer. This load balancer is going to be internal, not internet facing. Internal load balancer. All the requests would come to here, and then this load balancer would redirect my request to all the application servers. And let's say these two application servers talking to one database. Let's say relational database. And these two applications are talking to NoSQL database, depending on my use case. I can have this kind of a generic architecture. I can have it, like 3-tier architecture, normal 3-tier. So we need to implement these things. How can I implement these things? Let's do this. Okay, I hope I'm clear till this point of time. All good, guys? Please give me a quick confirmation. All good?
Yes.
Perfect. Okay, so see, as part of auto scaling group, one thing is very important. When the servers are coming up, the new servers, see how auto scaling works. It works on a particular condition. Let's say, understand this. Okay, I'm going to ask you this question. So let's say I'm a typical e-commerce application. I'm going to give you a scenario. Okay, I'm going to give you a typical scenario. Let's say 8 a.m. all our performance engineers, so we can understand this better. Let's say 8 a.m. to 11 a.m. on a particular day, I have 200 users accessing the application, and then let's say 2 servers. And let's say 11 a.m. to 7 p.m. I have, let's say, some 100 users accessing the application. Whatever, let's 2000, make it 2000, make it 20, make it 1000 users, make it 10 here, 10 servers. Let's say between 7 p.m. to 11 p.m. I am expecting 5,000 users accessing the application. And let's say this requires 50 servers. Let's say 11 p.m. to next day 8 a.m. Next day 8 a.m. I require, let's say, 1,000 users, and I need 10 servers. Okay, I'm going to ask you this question. So 20 servers, 10, 50, 10. Okay, understand this. I'm going to ask you this question. If I'm in on-premise, if I'm setting up this requirement workload in on-premise, how many servers I need to purchase? I need to set up to support the
50.
work. Yeah, 50. All good? Everyone on the same page?
Yeah, the maximum whatever is required for the business to run. The maximum.
You have to purchase it. You don't have any other option. You purchased it. Already done the hardcore investment. Purchase everything. 50 servers. What if I tell you, understand this, only for these 4 hours you need 50 servers, right? Apart from this 4 hours, how many maximum servers you require? Only for these 3 hours you need 20. Apart from that, only 10 servers mostly. Most of the time only 10 servers. Now tell me, if I find a mechanism where I just pay for 50 servers only for 4 hours, and I pay for 20 servers only for these 3 hours, and rest of the time I just pay for only 10 servers, don't you think over a long term I'll be cost efficient? Do you guys think that? I'll be able to save a lot of amount. Let's talk about the cloud. Let's talk about the cloud. If I tell you, you don't need to run 24 by 7, 50 servers. You will have to just pay for these 4 hours for 50 servers. Rest of the time, whatever the server you require, you're going to pay only for that. You're going to pay for 20 servers for these 3 hours, and rest of the time, only for you will pay for the only 10 servers. It is much less than running 50 servers 24 by 7. Yes or no? Absolutely yes. Much less. Significantly less. 50 servers running 24 by 7 versus this only for, I'm paying only for the 4 hours, running only for the 4 hours, 50 servers, running 27 only for 3 hours, remaining for rest 17 hours. I'm running only 10 servers. I'm going to significantly cost reduction. And that is possible through auto scaling group. Auto scaling group. That is possible through auto scaling group. So I will create an auto scaling group and I will write some conditions based on, let's say, one of the metric collection I will take, CPU. I will mention CPU utilization. That if a CPU utilization goes above 50%, create 2 servers. If a CPU utilization is less than 20%, decrease 2 servers. Hold on. Okay, so do you think will that be good? So CPU utilization greater than 50% for some duration. I need to monitor for some duration. I should not take immediate action. I should not be taking immediate action, guys. Do you think? I hope you guys agree. If I see CPU utilization greater than 50% for, let's say, 10 minutes, for 10 data samples, I see consecutively 10 times, if CPU utilization going higher than 50%, then definitely I think that CPU would be the contention and I need more servers and I can get it. So auto scaling group helps you create this kind of scenario. And CPU utilization less than 20%, let's say for 15 minutes, for 15 data points, obviously I am overly sized at a particular time and I can manage with lesser number of servers. I can decrease the number of servers. So scale out is the word we use to increase and scale in is the word we use to decrease. So I will scale out and scale in based on some auto scaling group. Making sense, guys? Everyone? Yes.
Could you please repeat? What about scale in and scale out?
See, as simple, right? See, you that first of all, my point was running 50 servers 24 by 7 versus running 50 servers only for 4 hours and 20 servers 3 hours and remaining 10 servers. Which is cost efficient? Which one is cost efficient? First, you need to understand that. Guys, are we together, everyone? Able to understand? Please feel free to unmute yourself, guys.
Yes, I can understand, Roshan. Thing is, right now everything is microservice world, right? So in this, so we are going increasing or decreasing the parts based on the utilizations, maybe say based on CPU utilizations. Now in this auto scaling group, so are we creating these conditions at namespace level or server level or cluster level? So which level generally I see mostly we use a pod level, right?
See, okay, first of all, I'm talking about a VM. Okay, VM. We'll come to the Kubernetes part later. Right. We have auto scaling group in Kubernetes also. We'll come to that, where to create, how to see. We'll talk about that. What I'm talking about right now, that are we on the same page on this auto scaling? Are we gonna it's gonna help us cost efficient or not? It's gonna reduce our cost or not?
Yeah, definitely.
Definitely. So that's what my point is right now. So we'll talk about how do we do auto scaling at EKS level or Kubernetes level, right? When we're talking about microservice level, how do we create it? See, it's always about the container level. We always create the auto scaling group, right? We call it HPA. We call it HPA and cluster autoscaler. It's just to answer a question. In Kubernetes, we use the word HPA, horizontal pod autoscaler and cluster autoscaler. These two things are there. First of all, we take care of a VM. In one VM, we need to make sure we utilize this VM completely. That's called HPA, horizontal. So in the YAML, we'll have to specify all these things in the YAML, and there will be a separate YAML for HPA. So I don't want to go deep into that. It will not make sense. So as I told you, right, I'm coming up with a course with all these things, right? All these things. I'm gonna just give you a glimpse of that course. Okay, just give me 1 second. So there are 2 courses. Okay. So this particular course is Cloud Performance Engineering and DevOps that I call it. Okay, I'm coming up with Isha Training Solutions. Okay. In this course, if you go over and understand that we are covering all of these topics. Okay? All of these topics. We're talking from everything from scratch, AWS, Linux, because I know that most of the folks, performance engineers, are very much we are comfortable in Windows. We are not on the comfortable on the Linux part. So Linux, ECS, RDS, microservices, then Docker, Kubernetes, EKS, then Java performance engineering. All of this we are covering here. And to answer your question, where we are covering this, if I go to the container orchestration, we are talking about these things. So in this part, in this module, I'm going to talk about this HPA and cluster autoscaler, how it works. I'm going to demonstrate you. I'm going to create a real cluster using EKS or GKE, Google Kubernetes Engine. I'm going to show you how it works. Okay. So if you are just want to go understand more about the course, you can go over this and understand. Okay, I'm going to give you this link. Okay, so coming back to the topic, okay, so always remember, so first of all, what we need to do, that we need to always start with a template. See, when I am creating, let's say my website is this, understand this, my website is this, amazon.com. My website is this, amazon.com. Okay, so let's say one thing, I want to ask you one thing. So let's say currently I have 100 servers running, let's say that, at one point of time. And let's say all of a sudden load came and I need more servers. So tell me one thing. So the new server which are coming should be pre-configured or not? Pre-configured, when I say, should the new server should display the same thing or something else? Should be the same thing, right? Every server should display the same thing. Yes or no? It should be pre-configured. The servers needs to be pre-configured. And that's where I will talk about, when I create the auto scaling group, the first thing that I will talk about is creating a template, right? I'll create a template and then I will go over all the steps here, choosing instance, launch options, configure advanced options. I'll talk about scaling policy. How do you want to auto scale? On what criteria? I will mention this criteria. How many servers you would like to get configured? So first I'll create the template and I will go over all these things. I will set up the load balancer. I will make sure my architecture is complete. That's how, and I'll give some conditions on what conditions I would like to auto scale. Then auto scaling would get created at the VM level. This is auto scaling at the VM level, right? And that is also we are covering here at the VM level auto scaling, right? So that's in AWS we are covering this elastic load balancing and auto scaling group. So at both the levels, like so at the VM level and at the Kubernetes level. So we are covering auto scaling at both the levels, right? So I think we would not be able to take this up. I think, yeah, no worries. We'll be taking up some more sessions, guys. You can join me in the demo session. Okay, we have a demo session. If you go over this link, let me see. We have a demo session coming. I'll talk more about this course. What are we covering and what are we not covering? So feel free to join me on 1st November, 9 p.m. guys. So I'm going to talk about this course, what this course is, right? And what are we going to cover in detail. Any question you guys have on on auto scaling or anything, okay, I may not be able to show you these things. It will take another 1 hour for me to complete this entire thing, and I'll talk about load balancer also, right? So any question I can clarify for you guys. That's all for the workshop, guys. Any question if you have, feel free.
Hey Roshan, Nadeem here. I just have a question.
Sure, Nadeem, go ahead.
Yeah, I just want to know about the deployment process when it is doing auto scaling.
Yeah.
So how in the new server we will do the deployment?
Correct. See, that's what, right? The first thing is template. Template means what should be the server configuration. So the way it works, that we create our own AMI. Okay, so if I just show you, just I'm going to click on create a launch template. Okay, I'm going to create this. You need to create your own image first. Own image, because see, when I say configure your own image, see, when I hit Amazon.com, right, when this page is coming up, it's preloaded with all the web pages, and web server is deployed already on this server. All these web contents are already linked up to somewhere, right? That's why I'm getting all these images. I'm displaying all the images getting displayed. It means web server is definitely there. All the images I can see. Yes or no? Right? So I need to create my own template first. In this template, I have an option to choose my own AMI. To choose my own AMI, the first thing they call is to choose your own AMI. Right? So I can do a quick start and I can create my own AMI, browse more AMIs. And I need to select my own AMI first. Or these are the AMI is operating system. So we have a process. Let's say first I'm going to tell you this. So let's say I create a VM, web server. I'm going to create a bare VM. I'm going to install web server in it. I'm going to make sure that all the web pages are getting displayed. And then I'm going to take an AMI for that. How it works, let me tell you. So let me show you. I'm going to show you a demo on this. Let me create an instance. Okay. I'm going to quickly create an instance. Server. I'm going to create a server. I'm going to install a web server. Okay. Let me call this web server. Okay. Let's just call this web server demo. I'm going to use this AMI. AMI is nothing but the operating system. I can select Ubuntu, anything. I'm going to select Amazon Linux 2 now. I am selecting here Amazon Linux 2. That's my AMI. It's free till eligible. That's next part is how much compute I need. I'm going to put 1 VCP, 1 GB RAM, just a free till eligible. I can go ahead and select any compute I need, I require, okay, as per my requirement. Key pair to login. Let me create a new key pair. I'm going to call Isha workshop. Let's say create key pair. That's how I will log in. Okay. And then I will, a security group is there, 8 GB. Let's say I'm going to create a launch instance. I'm creating a launch. First instance has been created. It's a bare. The server which I'm creating right now, it's a bare. Nothing in it. Just an operating system. Amazon Linux 2. That's all I have. Then what I need to do? I need to configure this server with whatever I need as part of my auto scaling group. What do I want to create, to provision, to deploy as part of auto scaling group? I need to configure this server first. How can I configure? I need to go inside this, log in inside this, and install whatever you need. Let's say I install web server. Let's say I'm going to do that. Let me just connect. Instance. I'm going to use instance connect just to connect. I can use putty. A lot of options I have. I'm going to use EC to instance connect. Easy. Okay. I'm going to connect to the EC2 instance. Okay. I just got connected to the EC2 instance. I'm connecting. I got connected to the EC2 instance. Okay. That's all. Let me install a web server first. I can be a root user. I can use yum install httpd is my web server. That's the httpd is the Apache web server, guys. I'm going to install this. Yes, I want to install this. I can check system. What is the status? System CTL. status HTTPD. Looks like it is down, but I'm gonna start this. Look at this, it's down right now, inactive. I'm gonna start this guy web server, whichever I installed. I'm gonna start this. Let's check the status now. It's running now. I can enable this so that next time when I boot, it's always up and running. Okay. I enable this web server. Okay. So my web server is running right now. It's deployed, and some web page would be also coming by default. Okay. So how can I check this? First of all, I need to enable the security group. I need to, in the security group, I need to make sure, because web server by default is deployed on port 80. Okay. I need to make sure that port 80 is open. There is something called security group. Okay. Security group is like a firewall. Okay. It's like a firewall. I need to make sure that port 80 is open. If not, I will not be able to access the web server. Currently, because I just opened the port 22, that's why I was able to SSH. If I want to access the web server, I need to add the port 80 as well. HTTP is the port 80. Okay. So HTTP is the web server. Okay. So I'm gonna just give everyone the access here. Okay. Save rules. Okay. Perfect. Look at this. So you can see this web server. I can access now. I can go to the instances, and I can just click on the public IP here. I copy the public IP and port 80. If I just access, this is my web server, guys. Just now I deployed the web server. So as part of auto scaling group, what I need to make sure this page comes up. Let's say this is the page. This is Amazon.com. I need to configure it first. I need to make sure whatever I need the content to be displayed, that has to be configured first in this server. This. So I will go to this particular URL where this index.html file is there. I will make sure I have all my things configured, whatever I need. Then I will take AMI of this as a template, because I need whatever I have configured first. I'll configure it first, and then I'll take an AMI of this image. AMI means your own AMI, your custom AMI. So if I take a custom AMI, let's say that I'm going to create an AMI for this. Your own image. So I have taken a bare VM, bare OS, installed a web server, enabled it. And if I take my own AMI right now, actions, image and templates, create image. I'm going to create my own AMI. Okay. So let's say AMI, my AMI, own. Let's say my own AMI web server, something of this sort. I'm just creating my own AMI. It's a web server AMI. Okay. I'm going to create it. So now I'm creating my own AMI, which is the pre-configured one. Now tell me one thing. As part of auto scaling group, if I mention that they need to use this AMI when the servers are coming up, tell me, will I get this page or not on the new servers? Nadeep, you asked this question. You could follow?
Yes, Roshan.
So if you see this in the my AMI, this is coming up. It's coming up. And what I will do as part of auto scaling group, when I talked about that, I'm going to create my own template. I'm going to use the same AMI as part of template. So whatever things are configured, that would be coming up. As part of my template, I'm going to select my AMI. Look at this, my AMI. I'm going to select this guy. If I select this guy as of template, any new servers which will be coming as part of auto scaling group will have this configuration, whatever I have used. Right? I hope you could understand in the overall picture the deployment part, how it works, and a lot of things goes into, right? Auto scaling conditions, criteria on when it will happen, and all those things, load balancer, health checks, all those things need to be taken care. But that's how the deployment works. You need to create your own template first. What you need to bring up, how you want to get it, what you want to provision, right? So it all boils down to your own AMI. So Amazon is using their own AMI, which is this configuration. You need to come up with your own web server. If you have one web server, you can take an AMI of that and you can use it. If I use the same AMI to create a new server, do you think I need to create again install a web server? No, I don't install a web server again, because in the new AMI, my AMI web server is already installed. Yes or no? Yes. So that's how it works. Okay. Any other question, guys? I can help you with. Okay, guys. Good. So silence. I always take the silence that we're all good. Guys, so please feel free to attend me to join me in this demo. I'm going to talk about this course in detail. You can go over some recording sessions also, some last batch. Okay. Just now I concluded with the last batch. You can go over this. If not, you can join me. You can ask me some more questions if you're interested to learn all of this, all things put together. Okay. So thank you, guys. I hope you have this link. We'll meet soon. Thank you.
Thank you. Bye.
Yeah, thank you.
Thank you, Roshan.
Thank you.
Bye bye.
Bye-bye.
Thank you, Roshan. Bye.